Hello everyone, Mr. Stevens here with our next algebra lesson. Today we're looking at a very important concept in algebra called like terms. And what we can do with these like terms is simplify algebraic expressions. First of all, what are like terms? Like terms are terms from an algebraic expression that have the same pronumerals. Okay, so let's look at this set of terms I have here and see if we can put them into groups of like terms. Okay, let's start with the first term, 4a. Now we're looking through the set of terms for anything that has the same pronumerals as 4a. And there's one term here, 2a, that does. Okay, 2ab is not a like term of 4a because it has a b and this one doesn't. But 2a has the exact same set of letters that 4a does. So 4a and 2a are like terms. Alright, let's look now at 5b. Is there any term in this list, we can cross these two out because we're done with them, that has the same pronumerals as 5b? And there actually aren't any. 5b has no like terms. You might think, wait, but what about this one? This one has a b squared though. It's not the same. B squared and b are different, so 5b and 7b squared are not like terms. 5b has no like terms. Let's look at our next one, 2ab. Can you see any like terms of 2ab? There is actually one here, and it's 3ba. This is a really important point, everyone. 2ab and 3ba are like terms because remember, this means 2 times a times b, and this means 3 times b times a. And what do we remember from BIDMAS and our orders of operations work that we started the year with? The order that we multiply things together in does not matter. So that means a times b is the same as b times a. Therefore, these terms have the same letters and are like terms. Okay, these ones have been dealt with. Moving on, 7b squared. Neither of these two terms has a b squared, and plus they have a's as well. So that means 7b squared has no like terms. Now, are these last two terms like terms? Yes, they actually are. 5a squared b and 9ab are actually like terms, because remember, when we write this out, we get 5a times a times b. That's what a squared means. It means a times a. And then what we have over here is 9a times b times a. And remember what we just set up here? The order doesn't matter. As long as we have a times b somewhere in the expression and a times b somewhere in the expression over here, they are like terms. They have the same pronumerals, 2 a's and a b. The order does not matter. Alright, let's have some practice at identifying pairs of like terms. Are 3x and 2x like terms? Yes, they both have x. Are 3a and 3b like terms? No. A and b are clearly different letters. 2ab and 5ba, are they like terms? Yes, because both terms have one a and one b, 1A and 1B. Remember, the order doesn't matter. Are 4K and K like terms? Yes. The number that comes in front of the letter doesn't matter when we're deciding if they're like terms or not. The only thing that matters is the letter the same? Sorry. Part E. 2A and 4AB. These ones are not like terms. There is a B here in the second term that does not exist in the first. They are not like terms. And last one, 7AB and 9ABA. Again, these aren't like terms because this term has a second A that is not present here. Alright, so now that we're pretty good at identifying like terms, what can we do with like terms? Well, let's see. Can we identify any like terms in this expression? Yes, there is a pair of like terms here. What we can do is we can reduce these two terms down to one term. And the way we do that is we take the numbers at the front and add them together. 7 plus 3. And there are no like terms for the 2, so the 2 is just going to stay as it is. You can think of this visually by writing it all out. We've got 7 B's here, and we're adding over here 3 B's. And if we count up the number of B's we have here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the total we have is 10 B's. So we may as well just write it as 10B. Okay, let's move a little more quickly through these last few. 12D minus 4D plus D. Okay, all of these terms are like terms because they all have a D. So we're going to be able to reduce this all down to one term. Now, what we have to do is we have to look at the numbers out the front and add them all together. 12 plus minus 4, which is just minus 4, plus 1. And that's going to equal 9D. Let's go down here for part C. 5 plus 12A plus 4B minus 2 minus 3A. Now, this is an important point here. Terms with no letter are also like terms with each other. So we can collect the 5 and the minus 2 together the same way we would collect letters. We can have 5 minus 2 at the front here. And then we've got 2A terms, a plus 12A minus 3A. And then there's only one B term, so it has to stay the same. So this is going to end up as 3 plus 9A plus 4B. So I would like you guys to have a go at D and E. And I will quickly write down the answers for you to come and have a look at after you've attempted them yourself. Okay, and now you guys are going to go ahead and practice some of these questions by going to page 357. You'll do all of question 1, and then you'll do 3, 4, 5, and 6, only doing the left-hand column of questions. Thanks, everyone.